JDK, an abbreviation you've probably heard about earlier as a Java developer or even a curious user. But what actually is it? How does it work and what does it consist of? What do parts like JRE, JVM, JDT, and how do all of the things work as a single entity? In this video, we will give simple answers to all these questions to make it clear. We would walk through all of the development steps where JDK is used, starting from writing the code to its execution. So let's start. JDK, also known as Java Development Kit. This is a bundle of tools for Java, and basically, this is like a basket that has inside different parts that works together, and each of the element does its own specific work. All of these elements are required to do any action with Java, so if you want to do any, like create Java application or just run Java application, we just need to download and install JDK, instead of downloading all of these parts separately. But there is one important thing that we need to know. There are actually many different versions of JDK, and each of them created for a specific combination of the operating system and processor. For example, if we use a device with Linux and ARM64 CPU, we need to use JDK which was designed directly for this combination of operating system and processor. The same situation with other devices. We always need to use JDK that matches with our device on which we want to run Java application. So the idea of JDK is pretty simple, and now let's go on and see what each of the elements does. The first key element inside JDK is Java Development Tools, or JDT. This is a collection of tools that takes user commands and performs various tasks. Each tool inside JDT has its own specific role, and together they form the core workflow of Java development. Here's what's inside JDT. The first one is a compiler. It takes human readable Java files, known as source code, and translates them into the class bytecode, which can be later executed on any device. On the right side of the screen you can see a real example of the compiler usage, and how our source code would be transformed into the bytecode. The second one, Java Launcher. It runs Java programs by executing the compiled class files. Under the hood, it delegates all of the work to other parts of JDK, but for us, all we need to do to run Java application, just to call Java Launcher. The next one is a doc generator. It takes special commands from source files and creates well-structured HTML documentation. The next util is Archiver. It packages multiple class files and resources into a single jar file, making it easy to distribute and run Java application. The last one, Debugger. It helps developers find and fix errors in Java programs by allowing step-by-step execution and inspection of the code. The debugger allows us to put our application on pause during runtime and get different information, which makes it easy to find errors in the application. So Java Development Tools is a part of JDK with which we actually interact when we work with Java. And the general idea of JDT is to take our commands, perform some work and return us the result of its work. The next element of JDK is Java Runtime Environment. This is a package that contains components which involved in code execution. These components are libraries, already implemented logic that is available for every Java application. It contains logic that is separated into different parts, such as utilities, part for working with lists, dates, maps, etc., network operations, database access, graphical UI, and other logic. So, in your Java code, you can refer to this logic, as during application execution it will be available. The next thing that we have inside JRE is a Java virtual machine. This is the main thing in Java. It takes bytecode from our application and transforms it into the instruction for the device. And as far as you remember, there are many JDK versions, and the main difference between each of them is JVM. Each version of JDK has a JVM which knows how to instruct the current device with a specific operating system and processor. So all of the existing JVM takes the same bytecode, but output differs depending on your CPU and OS. JVM simply knows how to translate bytecode to instruction for the device on which it runs. Also, JVM performs other operations such as memory management, thread management, bytecode verification and other important things. So let's summarize now. We have JDK, which has all of the parts required for Java applications. Inside, we have JDT, which has small applications that we call when we want to do any action related to Java. Also, JDK contains JRE, a part that is responsible for running Java applications, which consists of libraries and JVM, a thing that takes bytecode and transforms it into the instructions for the device on which it runs. From this point, let's see how all of these elements are involved in Java application lifecycle. The first step of the development flow is simply creating our application, a Java file with the source code. Once we've done it and our application is ready for the further steps, we step over to the next step, compilation. In this step, we call the compiler, which is a part of the JDK. It takes our Java file and converts into a class file. The general idea of compiling the code is to protect our application from readability, ensuring that no one can easily access our source code or see how it's implemented. After compiling our source code to the bytecode, we proceed to distribution, uploading our application to the cloud, from where all final users can download it. Once our application is shared with other people, it's time for application execution by the final users. As far as you know, to run Java application, each user must have the JDK installed on their device. After downloading our Java application, they invoke the Java launcher, which delegates the entire application execution process to other JDK components. Under the hood, the Java launcher provides our class file to the JRE, which in turn gathers the necessary libraries and our class file, passing this bundle to the JVM. At this stage, the JVM plays a crucial role. It translates the bytecode from the class file into machine code that the underlying operating system can execute. Then, operating system takes this machine code and sends it down to the CPU for processing. It's important to note that all of the previous steps, compilation, distribution and launching of the application, remain the same across different operating system and hardware. However, starting from the JVM, the process varies depending on the platform. Each operating system and CPU architecture requires a different implementation of the JVM to ensure the compatibility and proper execution. This platform-dependent nature of the JVM is what enables Java's write once, run anywhere capability, allowing the same class file to run on different systems. And for sure, if you want to check how our application would work without deploying and sharing our application with the final users, we could follow all of the steps locally, what we as developers usually do. So that's it. Now you know what is JDK and how it works. If you still have any questions or ideas, you could leave a comment for discussion. And if this information was useful for you, I would appreciate your like and subscription. Thank you and see you on the next one.